Welcome back. In this video, we are going to solve a structural design problem that involves a column design using LRFD method based on eStructural Design Zen found on the App Store. Design a reinforced concrete circular column using load and resistance factor design that carries an axial bending load with axial dead load of 1,400 kN and axial live load of 2,700 kN, with moment dead load of 210 kN-meter and moment live load of 405 kN-meter. Design criteria as follows: strength of concrete 49 MPa, vertical bars 25 mm bar grade 414, spiral tie bars 12 mm bar grade 414, steel ratio 2%. Given axial dead load equals 1,400 kN and axial live load equals 2,700 kN, the factored axial load is 6,000 kN. Given moment dead load equals 210 kN-meter and moment live load equals 405 kN-meter, the factored moment is 900 kN-meter for an eccentricity of 150 mm. Enumerate input parameters required. Column name C13, floor designation, footing to second, shape and ties, circle and spiral, steel covering 64.5 mm, unsupported height 3000 mm, vertical bars 25 mm bar at grade 414, steel ratio 2%, spiral tie bars 12 mm bar at grade 414, strength of concrete 49 MPa, factored axial load 6,000 kN, factored moment 900 kN-meter, and eccentricity 150 mm. Given steel ratio equals 2% and assumed column diameter equals 635 mm, the area of steel is 6,333.84 square millimeters, and the number of vertical bars for 25 mm bar is 13. The spacing between bars is 122.28 mm and 97.28 mm for clear spacing. To get the nominal load and moment at E equals 150 mm, let neutral axis C equals 475.6 mm and height of stress block A equals 332.92 mm. Given diameter of column equals 635 mm and steel covering equals 64.5 mm, follow the given computations to get the distances of each bar from the edge of column and force type relative to neutral axis. D sub 1 equals 64.5 mm less than neutral axis, compression. D sub 2 and D sub 13 equals 93.48 mm less than neutral axis, compression. D sub 3 and D sub 12 equals 173.78 mm less than neutral axis, compression. D sub 4 and D sub 11 equals 287 mm less than neutral axis, compression. D sub 5 and D sub 10 equals 407.22 mm less than neutral axis, compression. D sub 6 and D sub 9 equals 506.87 mm greater than neutral axis, tension. D sub 7 and D sub 8 equals 563.15 mm greater than neutral axis, tension. Follow the given computations for stress and force of each bar. Stress at D sub 1 equals 414 MPa with compressive force equals 203.222 kN. Stress at D sub 2 equals 414 MPa with compressive force equals 203.222 kN. Stress at D sub 3 equals 380.765 MPa with compressive force equals 186.908 kN. Stress at D sub 4 equals 237.931 MPa with compressive force equals 116.794 kN. Stress at D sub 5 equals 86.266 MPa with compressive force equals 42.346 kN. Stress at D sub 6 equals 39.45 MPa with tensile force equals 19.364 kN. Stress at D sub 7 equals 110.45 megapascal with tensile force equals 54.217 kN. Stress at D sub 8 equals 110.45 megapascal with tensile force equals 54.217 kN. Stress at D sub 9 equals 39.45 megapascal with tensile force equals 19.364 kN. Stress at D sub 10 equals 86.266 megapascal with compressive force equals 42.346 kN. Stress at D sub 11 equals 237.931 megapascal with compressive force equals 116.794 kN. Stress at D sub 12 equals 380.765 megapascal with compressive force equals 186.908 kN. Stress at D sub 13 equals 414 megapascal with compressive force equals 203.222 kN. Given Fc prime equals 49 megapascal and area of stress block equals 168,133.936 square millimeters, the force of compression block is 7,002.778 kN. By summing up all the forces, the nominal axial load is 8,157.378 kN. Follow the given computations for a final check of eccentricity at 150 mm. Given nominal axial load equals 8,157.378 kN and E equals 150 mm, the nominal moment is 1,223.607 kN meter. Check for adequacy. The nominal design load of 8,000 kN is less than 8,157.378 kN actual load capacity. The nominal design moment of 1,200 kN meter is less than 1,223.607 kN meter actual moment capacity. The spiral steel ratio ρs equals 0.01646 for a spiral pitch of 48 mm. Design recommendation as follows. Fc prime equals 49 megapascal, Fy equals 414 megapascal, column size is 635 mm diameter by 3000 mm, vertical bars of grade 414, 13 pieces, 25 mm bar, spiral tie, 12 mm bar of grade 414, pitch at 48 mm on center. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.